Hello, I'm Serban Teodorescu. I'm working in Adobe for the last 5.5 years, and in the last 4 years or so, I've been working with Cassandra in an Adobe project, Audience Manager. This time, I'll do a quick story of how we've done two major system upgrades of Cassandra instances using a method that I've stolen from Netflix at an ApacheCon presentation. And this is how we'll probably do the upgrade to Cassandra 4.1 when we'll do it, which I hope will be soon. And also I should apologize that I didn't have time to rehearse this, as a couple of days ago I had an unfortunate emergency room visit. But so we can go to the next slide. So as I said, this started at ApacheCon 2019. There was a very interesting Netflix presentation hosted by Joey Lynch, named How Netflix Manages Petabyte Scale Apache Cassandra in the Cloud. The presentation was not recorded. This was before the pandemic times, so things were still happening only offline. But the slides are available at the link that I included. There were many interesting ideas there. Among them, that's concerns that about the imperative versus declarative control plane, and also software migration by using immutable EMI, and this is described in that in a Medium Netflix blog post. And this was from their presentation. The idea is that you have AWS instances with local data stored on instance store. This is data that is not being persisted when the instance is stopped. So you cannot just replace the root image. What they were doing instead was determining that an image needs to be updated, installing a special Ubuntu bootloader on top of the image, booting into that Ubuntu, and then in turn that one is not doing a full boot, but doing some booting tricks, some old sysadmin stuff to get the image from S3 and overwrite the disk before the root disk is actually mounted. As I said, all the sysadmin stuff. Back to our setup, why we have this problem. It's where we have 34 clusters in 8 AWS regions with replication factor 2, which is a bit strange. Usually to do a big upgrade, in this case we had the OS upgrade, as I mentioned, we would have done, we'd have used simply replace each instance, but doing that on 1,000 instances, it's you are just asking for problems. It's anything that might happen will happen when you do it 1,000 times. And even worse is that we have to do it on 34 different clusters. So I already knew that that wasn't an option. Applying the Netflix solution implied having EMI already baked with Amazon Linux 2, NewOS, and Cassandra pre-installed. That means no terraform to plan apply. Using the same hardware and just replace the root without moving any kind of data around. And here I have a nice story that at some point I was discussing this with AWS support, and they had really big problems in understanding how we can move the data around. And they're saying that there is no way to move 1.9 terabytes of data in 10 or 20 minutes, as we were, and they were failing to understand that we were not moving the data, we were actually switching the root EBS. So that was a fun moment to explain them how things are working in their systems. Several nice things. What this was very consistent. It was always going between 10 or 20 minutes when it was working. So how we implemented it, we used, because Netflix is open sourced, only the bootloader stuff and Ubuntu image. Implemented the DynamoDB cluster lock. It's easy to find this on Google. We are already using Puppet and using that for control which instances are going to be upgraded per instance, per availability zone or the entire cluster, and a bunch of Python scripts called from cron tabs installed by Puppet. And on the first, as a note, and the first upgrade, we had to move some folders to a different EBS volume so that between replacements, some data is being kept, such as logs or instance names and so on. On the first try, we had, if I remember correctly, about 5–10% instances stopped due to various problems, mostly due to hardware, because AWS has a hardware integration for YAM, and that was blocking S3 access. We are on a limited time, so we had no metrics. You can see on the second execution, I managed to install some metrics, and this is an example of running in parallel on 5 different clusters, and each of those nice lines is lock being held and then released and then moving to the next instance in a distributed manner. But this was only on the second execution, when we had to install the security agent that required reboot. And maybe we'll share this in a blog post as well with some more details. That's all.
That's great. Good job. You got through it in 5 minutes. Well done. And yeah, a blog post. I think we know people. Yes, that would be great on the Cassandra website for sure. Or on your own Medium. We would love to talk about it.